Good afternoon, everyone. Thank you for joining our webinar today. So today our webinar topic will be BIM and IBS, perfect match for productivity. My name is Lisa and I'm excited to be here today. Before we begin, let's go over some guidelines and housekeeping items to ensure a smooth and engaging webinar experience. Kindly keep your microphone muted throughout the session to minimize the background noise. If you have any questions or comments, please use the chat box on the right-hand side, and we encourage active participation. So feel free to ask questions and comments if you have during the Q&A segment. And I also have shared a link in the chat box. Please kindly register your attendance at the link given because we will be providing the e-certificate and also CPD points. So make sure that you have registered to the link given. And now let's introduce our speaker for today. We have Mr. Nazrul Ashraf, our BIM coordinator, Bina initiative, and he will be sharing to us regarding the BIM and IBS perfect match for the productivity. So now let's welcome him to share his experience in a BIM and IBS.
Okay, good afternoon, everyone. Assalamualaikum to the Muslims. Okay, and to everyone, a very good afternoon to all. Okay, let me share my screen a bit. Okay, so again, welcome to Bina Initiative webinar as introduced to by my good colleague, Lisa. My name is Nasro, and I will deliver a speech on BIM and IBS perfect match for productivity. Okay, so as the title would see, the BIM and IBS is uh, actually has been a long time in Malaysia. Okay, so there's a perfect match on this two distinct features of technologies in Malaysia. Okay, so here is my brief introduction. Okay, I am a BIM coordinator here at Bina Initiative, and I've been 8 years experience in AEC industry, architectural engineering and construction. Okay, 5 years in BIM industry. I was experienced in Singapore, Malaysia, and some part of the rest of Southeast Asia. And I'm still going strong to advocating and spread awareness on BIM. Even though I am a BIM coordinator, which handles the project and handle the project directly, I'm also educating to the people that are very much keen with the latest technologies. Okay, so let's move on. Okay, BIM and IBS in Malaysia. Normally, when we encounter the clients or any people who take part on interested in BIM or BIM and IBS. So there's a common conversation in these people. So some part of it like saya ingin BIM-kan project saya. Okay. And for the IBS, kita pakai IBS. The project duration should be shorter. So this is one of the common, what we call it, being a misconception between the industry players. And for the contractors outside there, okay, and this is only part of what we can see is the good side of it, okay, but there's a lot of effort and hard work that put into motion, and it can become success. Okay, right. So saya ingin BIM-kan project saya. So BIM is, when we talk about BIM, we need to have a throughput on the on the what is the project need and the requirement, okay? And then we do a planning. There's a lot of planning in the motion, and we want to work on towards to the BIM. Okay, it's a process and it's not a magic word. Sa ingin can BIM. And for the other side of IBS, sure, it will shorten your project duration, but it will not totally shorten your duration. Abracadabra, it will be shortened from 4 years of project duration, it will turn into 1 year project. It can be, but it will depend on the complexity of the project, the structural behind it, and how big the scale of the project. And we need to be to face the reality that IBS can help us to shorten, but it will not be a magic word for us to shorten the project as entirely. Okay, right. Next, we have a outline here. Okay, so we will have an introduction BIM and IBS, benefit BIM and IBS, and case study that we've been in this project for less than a year. What we did is to plan and model throughout the planning from the design stage to the construction stage, which is took only 4 months. Okay, now they have started to work on the IBS and they have started to ramp up the production on IBS panel. And now we are at the stage under substructure. Okay, right. So a brief introduction on BIM and IBS. So BIM is Building Information Modeling, and it's a short form as a BIM. Okay, and it's a process using virtual and technical data into a model of building or infrastructure. While IBS, Industrialized Building System, refers to the prefabricated of structural components which should be assembled into a building or infrastructure. Both are two distinct technologies, but complementary concept in construction. Okay, so both are two different technologies, or what we call it a method. So both are in a modern way that we call it in the construction industry. One is BIM, which is a virtual, and IBS is a physical assembly. Okay, in the past or now we are still going on, we still using a conventional method, which is we do in situ or on-site concrete casting, where we put up the formwork and then we cast and pour the concrete into the formwork, and then after curing for 14 days and above, then we will start dismantle the formwork. There we can say it's already done with the structural out. What with the IBS, what we've manufactured, we prefabricated in the factory, which is isolated lah. Okay, so we can control on the quality and the manpower as well as the condition of the environment. Then after that, we will deliver the precast or prefabricated IBS on site, and we will assemble it on site. Okay, while for BIM in the past we're using hand sketch. This is before that maybe our ancestor, maybe our great grandfather, we use a hand sketch on manually sketching on the technical drawing. After that, we have a computer aided design, which is CAD, or usually commonly that we call it as AutoCAD lah, but AutoCAD is a product. What we use it, we draft all this technical into AutoCAD, and then it will come out as a file of a CAD drawing. Okay, now we have a BIM. Okay, so BIM is a part of a IR 4.0. So what is IR 4.0? IR 4.0 is a industry revolutionized 4.0, which is now, and it will go further, which is by using all the latest technology, which is by using internet of all things. And the technology will going strong by using the collaboration of all technology. Okay, now we don't have any more manual things, but still there's some part of it by using CAD. But BIM in Malaysia, we want to push it further, because the other country we have like Singapore in our neighbors, they have adopted at least last year it was 80% for all the project in Singapore. Okay, but in Malaysia right now, we have adopted we have adopting like 55%, if I'm not mistaken, that was reported by CIDB Malaysia. Okay, so let's move on to the definition of BIM and IBS. Modeling, technology, and associated set of process to produce, communicate, analyze, and use of digital information models throughout construction project life cycle. Okay, this is sourced by CIDB Malaysia. So it was defined by, there is no fixed definition on BIM, because every country they have their own definition, but in some ways and in the we focus on the single point, which is to communicate, analyze, and use of digital information model. So digital representation is BIM, which is the visual of the building or infrastructure. So this is most of the definition by the other countries and regions. This what we can call it as a digital representation of a building or infrastructure. And next, we have the IBS, a system or method of building construction in which the components are produced in controlled conditions in the factory or on a construction site, transported and installed during construction with the minimal use of workers on site. So this is also reported by CIDB Malaysia. Okay, so CIDB is our it's a Malaysia authority on construction industry, and they have been researching, and they have been surveying, and they have been pushed the agendas on the IBS a lot. In this past years, I think we have adopted around 30 to 40% projects in Malaysia. So in private sector, we have adopted, I think it was searched more than 50%. So this can deliver in a shortened time, but by reducing the cost of the project. Okay. Next, we have. So next we have I have a video. Okay, so this short videos it was a partnership with our partner with Gamuda. Okay, so let's take a look on the video here, and let us know afterwards we have a Q&A session. Okay, let's start now.
Modeling, or BIM, a digital process that integrates the design, construction team, and all relevant stakeholders, improving precision, speed, and coordination from design to delivery. BIM is a digital platform that provides real-time access to project information, enabling visualization of product throughout the development stage, thus making informed decisions to develop it. BIM enables our designers to analyze and optimize each design and development to achieve higher Green Building Index or GBI scores. The conceptualized 3D designs are then further developed by combining architectural, structural, mechanical, electrical, and plumbing elements. BIM is capable of analyzing these integrated models using the clash analysis, and any design clashes can be amended, thus reducing errors with increased efficiency. These integrated models also incorporate the elements of time and cost, enabling the construction program to be visualized virtually. Homes for Gamuda Land projects are constructed by Gamuda IBS, Malaysia's first fully automated digital industrialized building system factory. With this technology, homes are produced with stringent quality standards. Construction is faster. Wastage and environmental pollution during construction are...
Okay, so that is how BIM and IBS collaborate into a single project in a shorter by explaining in a short amount of time lah. Okay, so let's move on.
Modeling or
Okay, so the advantage of BIM and IBS in AEC industry. So I put it in a separate statement here of for BIM and IBS, and then we can come together how the benefit of the collaboration and integrating the BIM and IBS that will shoot up the productivity. Okay, now we start with BIM, BIM. So geometry information. So by having a BIM, we can have a detailed 3D representation of geometry. And by just now, we have went through the video that we can see there's an infrastructure, there's an architectural component, structural, mechanical, electrical, and plumbing. Okay, so having all this, what we can say is we can coordinate all of this within one software. Okay, so in this software, when we coordinating all this, we can reduce the time for us to encounter any discrepancy afterwards. Okay, so during the construction, we can avoid all of this discrepancy and issues on site, right? So when we saw this early on, we can make a change directly before the construction even start. Okay, so that is geometry information. We have the geometry information of all the things. Okay, next one we have a spatial relationship. Okay, spatial relationship is a space where we use by calculating all the space that we have that we are occupying and what are the space that are left. Okay, so this is good for the architecture. So architecture can foresee all of these components when they place it on the layout of a building or infrastructure, and they can plan it ahead by putting a spatial relationship of all the other trades. So the other trades such as the structural, mechanical, electrical, and plumbing. So having this early on, we can manage all this space in a very efficient way. So without having to change it during the construction stage or after the construction stage. Next, we have a quantities and properties. Okay, quantities and properties, we can extract it after or during the planning process and designing process. So when we're putting all of these components in a BIM, we can extract it out the quantities and properties of the element. Okay, so what we call it in the components in the software platform of BIM, we call it element. Okay, so these elements, when we extract it out, it will assist architecture, engineer, and quantity surveyor to know what are the latest and what are the quantities in the real life project that are ongoing. So having this, they can cross-check it without the need to check it manually, right? So they can just automatically or by inputting a template to extract it out the quantities. Next, we have a maintenance and operation information. So after construction, construction stage, we have a as-built stage. So as-built stage, it's a stage where we verifying all this information from BIM and on-site. So this, when we see that the information are tally, afterwards we can put it as a facility management for maintenance and operation. Okay, so by all of this information, when we hand over to the facility management system or FM system, they can actually know the layout of the building and the position of the components which is required for maintenance and operation. So they can pinpoint it accurately and they can know what are the information behind of this component. So such as when we put it in the components, there's a warranty. So the warranty is 5 years. So the 5 years warranty are inside the information of the component. And they can just look at it, click it, and then they will see it. Then we can see the information of the brands and the just now I mentioned about the quantities. So they can check all the quantities in order. So how much of the quantities that they need to replace, that is such instance that we need to replace. Okay, if we need to replace, then they have the accurate data of the total components and what are the right brands that they need to purchase it. Right. Next one, we have a regulatory compliance information. So in this as-built stage or in the afterwards that just now I mentioned about the FM system, facility management system, we can also inputting the regulatory compliance information. So we have the bomber requirement, and we have a building and KM all this certification, and we can input it in this in a very convenient way in a one source of a file. So anyone that in the FM system, they can already know what is the inside information that they need, what that they are required. So let's say the lift needs to be audited or to be checked by the authority. They have the certification inside the data of the model. Okay, so this is one of it, of the regulatory compliance information. Then we have the historical data. So having the historical data, we know what has been going on in the past 5 years, in the past 10 years, and so on. If we say it, this project has been, or this building has been going on 10 to 15 years ahead. So on that time, BIM was already established and the project was already done in BIM, and FM system was integrated in BIM. So during this period 10 to 15 years, there might be maintenance and service operation during this period, and they can, we as a staff for the maintenance and operation can input in what we have been doing in the period of 1 year, 2 years, or 3 years. Okay, so let's say the service has been done this year, and this year. So the next staff or the next person that will take in charge of the building, they will see the historical data. Oh, this has been serviced, or this haven't been serviced yet. It's already 5 years. So some sort of that. Okay, now we go on for the IBS. All right, so IBS prefabrication. Okay, so as everyone knows, IBS, industrialized building system, is a precast, but it was planned to be industrial standard for precast. Okay, so IBS usually what we do is for the building. So the building will have a integrated beam system. Okay, so they will have a beam, they will have a wall, they will have a column, they will have a slab or floor. So all components that I've mentioned, it's a prefabricated in factory, right? So so when we put it in the factory, or what we manufacture in the manufactory, we can control the quality, right? So when we control the quality, the product will come out even better and excellent compared to the conventional. So conventional, we have the on-site in situ casting, which is the usage of formwork a lot, and then we have a wastage on the steel, concrete on site. That is one of the wastage, and then the finish that we cannot control on the on situ casting. Okay, so having the prefabricated on the components in the controlled environment, we can control much everything that for the IBS component. Okay, next one, assembly. So the finished part of the prefabricating, we need to assemble it on site. So anyone played Lego before or still playing Lego? So Lego is one of the simple method, or what we can see another term how we see the IBS. Okay, so you just attaching or stacking all of these components like Lego, and then it will come out on the top floor by floor until it become a one structure. So this assembly on site, after we deliver the panel, right? So it will start to assemble on site in much shorter duration. Okay, so on site we have a planning where we can see there's a panel, what we need to put it first, what we need put it later. So to assemble it on site is it's not easy, but it takes a competent person or skilled worker to do the assembly process. Okay. Now we have a standardization. So IBS encourages the standardization of building components, leading to increased efficiency and reduced waste. So having the IBS, okay, in Malaysia we have CIDB as our authority body, okay, and they have the Department of IBS, which is they also have a rating score for the IBS project. So such as for the project, they have a few criteria. So you can later on after this, you can take a visit on the website on the IBS. Okay, so they have a credit score on the IBS. So having this standardization for the whole or fully IBS project, you can gain we can gain a score mark, if I'm not mistaken, it's 50 score rating. Okay, so let's say there's a building, and some of the building they are still using the conventional. Some part of it they're using conventional. The rating of the score will start lower down. This rating they can show it to the stakeholders as a or to the buyer that we're saying that this building, some part of it there's a conventional work, but most of it are being most of it are IBS system. So having this, we can attract the buyer actually. Okay, so buyer or the investor or saying, oh, this is an IBS project. It's a good project because it has less defects. Okay, so the quality, what we can say, compared to the conventional way of construction, it's way better. Okay, so buyer will just see this as a standard of benchmark of the of a building. So let's say you want to buy a house and you see there's a house, the house is one is a conventional and another one is IBS. Okay, you can maybe you can compare when the construction starts and when the construction is finished. When you see this, the duration, you can see the conventional maybe takes up more than 3 years. Okay, depending on the scale of the project. Okay, let's say the high rise. Okay, and for the IBS, it takes around 1 year, 1 year and a half, or maybe or 2 years. Okay, and you can see there's a lot afterwards there. You can do a comparison. Oh, this building for the conventional construction, they have a lot of defects, and for the IBS, you can see there may be some defects, but it was controlled uh, to to minimize all this, what we can avoid during the conventional way. So as a buyer, you might be biased towards to the IBS. Okay, so this gives us to the confidence to the buyer and to the investor. Okay, next, we have a quality control. I have mentioned a lot on the quality control. So having the prefabricated on the manufacturing or or in a factory, it was done by the robot. So robots in the automation, they will do this to reduce the human error. But still, if it's the design it's wrong, so the robot will do as wrong as what humans do lah. Okay. So what we can say is we can still reduce or minimize the error, but it will still depends on the human factor. Only that we have reduced it. We have reduced it further to not further the damage of the design lah. Okay, so having the quality control, the control environment of a factory in IBS enhance quality control as components can be manufactured with precision and consistency. Okay. So the next one, the benefits of BIM and IBS integration. Just now I have went through what are the advantages of BIM and what are the advantages of using IBS. Now we come to integrated both of it into one single method. Okay, so having BIM and IBS integration, it enables accurate site analysis and visualization, allowing stakeholders to assess the impact of the project on the surrounding environment and infrastructure. So having this to the project, it will impact directly or indirectly. So having let's say for the instance, having the conventional way, we might or we may have spent a lot on the material. So all these raw materials, when we done it on site, some of it maybe spilled over, some of it maybe there's a defect before the construction starts going on, and there's a lot of factor like maybe rain, then after the rain they wash up all the sands, all the salts and cement. This will impact on the environment. Now, how about the IBS? IBS is already done on the manufacture on the factory. So the factory itself control all this wastage, what the amount of the concrete that need to be done on one single panel. So they will have a total of cubic meter, how many, and how many meter square that they need to create a mold for the IBS panel, and they control it that such way when they come on the delivery on site, they will only have to install it. So not much on the environmental impact during the construction or during the assembly process on site. Okay, compared to the conventional way, there may be a carbon footprint a lot, so there's a lot of large heavy vehicle on site. Okay, so all those the carbon gases that release to the air. Okay, so this is part of the environment that are impacted. Okay, now we have next one, we have a minimalized human error. Okay, just now I mentioned the quality control, so the minimalized human error here is where the part in the conventional way or in conventional construction, when we've done it wrongly on site, it will take some time to rectify it. So let's say for the one part of the building, you might take a lot, maybe 2 or 3 weeks to rearrange back the materials, okay, and then maybe you need to hack it back, or maybe you need some time for the consultants to do a alternative so that to mitigate this error. Okay, now how about the IBS? So by using BIM and IBS, BIM is already a visual model of the building or infrastructure. So by having the visual correctly and you pass it on the manufacturer to the factory, and it's already been it's already correct on the model. So you have to minimize the error when you have been the design have been designed in the correct way, and there's no jeopardize on the designing. So now it's a part up to the automation. So having the automation, we using a CAM or CAD, and then we send it a signal by inputting the information to the robot on the factory. They can do it accurately. Okay, so having this, we have minimalized a lot on the human error. Okay, but still it will depend on the how we operate it. Okay. Okay, next one, we have a BIM support pre-planning of IBS design. So BIM, having BIM is we can pre-plan it before the design process even begins. So maybe we will begin it as a concept first, and then we will do the work towards until the design stage. Okay, so having this period is important for the IBS because IBS there might be limited time or space on site. Okay, so we can do a pre-planning this ahead before the production of IBS. Okay, next one, we can provide insight in holistic approach of IPS adoption due to feedback information from BIM. Okay, so when we do an analysis on BIM of a IBS component, the components might have clashes with the other trades such as the mechanical, electrical, and plumbing. So having all this, to avoid these clashes, and we can do a input by giving a feedback to the IBS design, or this need to have an opening for the pipe to come out. Okay, so this give a lot of advantage on the IBS instead of conventional way. So conventional way, they need to look at back on the drawing, or they using BIM, or maybe they already have casting on that side, and they will need to do a hack on that part. So IBS have done it early on. Okay. Next, we have a IBS accelerate project productivity up to 300%. So 300% is too far-fetched on how the reality of the project. But this one, it was reported by the CIDB Malaysia. So IBS achieved 10.4 square feet per man day compared to conventional 2.3 square feet per man day. So there's no extensive elaboration on this, how you can achieve. Okay, so it was reported by CIDP Malaysia. IBS achieved 10.4 square feet per man day, which might be during on-site assembly. So all those components have been done on the factory. Now it's up on site to do a delivery by assemble all these parts into floor by floor of the building. Compared to the conventional one, they need the main day for the workers to do is 2.3 square feet, okay, per main day. So let's say for one workers, they can only make up 2.3 square feet for one day. That is only for one worker. Now we have workers in IBS, they can achieve 10.4 square feet. So all of this differentiation, I can come up with 300%. That is quite a lot. But what I can say is 300% is not it's a fixed variable. It can be manipulative variables, because there might be a site condition, there might be a workers condition, resources condition, the future rates, prices. These all of the factors can affect the project productivity. But again, having IBS is already it can be accelerate up to 300%. You can accelerate maybe 20-40% compared to conventional way. It's already enough, right? So you can reduce from the 3 years into 1.5 years. Is already good enough, right? So sometimes we need to do a reality check on how do we want to approach on the project. So it can be affected a lot of factors. Some of it are complexities of the project. So if the project we have a flaw which are typical, so typical can be done very much easier and right? But if you have a floor which is some part of it here is maybe type A, here with the other floor we have a type C, type D of things, of an area. There's a lot of things. This can be factored, can reduce the acceleration of the IBS project. Okay, but this if we compare it to the, but still if we compare it to the conventional way, it can it's still good enough. Okay. Okay, so software platform for IBM for BIM and IBS productivity. And this is commonly that we've been doing in our industry in Malaysia. Okay, we use it Tekla for engineering design analysis, which is the structural, okay, the structural part, and then we have a Revit as an integration, virtual design, and coordination. So Revit as a part of a we can collaborate it with the Tekla. Okay, so there might be the other software for the architecture that I've been doing for the IBS, maybe a SketchUp or maybe just with maybe brisket if you ever heard of it, but most of it may we can say SketchUp part of the architecture tools for BIM. And just recently, I see that a lot of consultants have been doing in Revit for architecture. So it's good because we have a one single software to do a collaboration with the other consultants or trades. Okay. So next one we have a all plan precast. So all plan precast is a tool for CAD CAM production and precast automation. So having in our disposal of a Tekla and Revit, these two can produce IFC. What we call IFC is industrialized uh, industrialized standard. Okay, so this format we feed information to the all plan, then it will come out as a CAD and CAM production for the precast automation. Okay, the next one, we have a Autodesk Navisworks Manage. Okay, so Navisworks, we use it as a collaborative point where Tekla and Revit, we have these two information, so we can do a coordination with all the stakeholders. Okay, so we do a virtual coordination, review, and simulation. Okay, simulation, that's the important part. So simulation, we can put, we can do a simulation in the timeliner, which is what is the stretch or duration of the project. So we can try to put it in the Navisworks, and then we can start planning ahead, part by part, what are the areas that need to be done first, what are the areas can be done later, what are the areas can be prioritized first. This is all can be done in the simulation. Okay, and then we can see the simulation along with the duration on the week one until end of the week. Okay, next one. Okay, so we have a case study, BIM and IBS. So Pantra Central Park 3 by IJM Land. So we are the BIM consultant for this project. Just now I mentioned that we have been done this for the 4 months on the ahead on planning and coordinating and producing BIM BIM model to the IJM. Then they will hand it over to the IJM IBS for the production of the IBS panel. Okay. So this case study, a collaboration between Bina and IGM IBS. The project name, as you know, is Pantai Central Park 3. So there's a 34 floors stories. Okay, then we have IBS floor level 7 until level 32 for the residential tower. Okay, so below level 7, we have a level ground floor level. Underground floor level, ground floor up until to level 6. Okay, so this level we using a conventional way. So this conventional way to what we can say, the volume of the volume and the size of the components are too big for the IBS to be done. Okay, so this is one of the factors which I have mentioned before, the complexities of the design. Okay, so if there is a size or volume of a large volume of the components, it might cannot be done by using IBS. Okay, but still we have reduced a lot of the factors by having few floors just using conventional. So this is hybrid way to do the IBS. Okay, so having a typical floor from IBS floor level 7 to the level 32, we can control all the residential unit in a way that we can come out it as a good finish of the quality. Next, we have a BIM goals. We can what we did in our scope for this project, we do a 3D model creation, coordination, architectural, structural, MEP, clash detection, quantity extraction, method statement, 3D visualization, and design analysis. And we've been doing this for the LOD, or level of development, 350 and 400. So a short brief on 350. It's a construction, design to the construction, and then 400 the construction to the as-built stage. Okay, sorry, not as-built stage, it's a shop drawing stage. As-built stage is 500. So this is one of the BIM and IBS workflow here. As you can see on the figure here, we have a process set from the IGM IBS, how they can do the process on the production. And we do have a single point of the platform to be collaborate with IGM IBS, and then we have the feedback on the information there. So this is what we call it BIM 360. It's a CDE platform, what we can call it a common data environment platform. Okay, so all this information we are sharing, we are collaborating with the consultant, with the contractors, with the manufacturers, and with the other stakeholders and and the owner itself. Okay, so they can know what are the progress of the work, what has been done just now, what has been done in the past few days ago. Okay, next, this is outcome in stages. We have a 2D CAD. Okay, so the 2D CAD coming from the design process, and then we start reconstructing back in the BIM, and then we have a flash analysis and coordination, rebar design analysis, IBS mockup, costing, prefabrication, and construction. Okay, so this is one of the example of the drawing. Here is the beam and clash analysis and coordination. So here is the rebar design analysis. So this one has been collaborative analysis with IGM IBS and the structural consultant. Then we do a IBS mockup. Okay, so we put the IBS mockup as a way to know and to see how does it look for the final product. Okay, so we need a mockup to look at what we can improve, what we can reduce it. Okay, so this we can minimalize further when on site the penalized the penalized of IBS deliver on site, and then they found out there might be a discrepancy, there might be issues on during the assembly process. Okay, so having the IBS, having this mock-up gives us a lot of insight. Okay. Next one, we have a costing. Okay, so just now I mentioned that we can do extraction on the quantities and the properties. Later, we can put the cost of each of the quantities. Okay. Then the prefab process. So all these prefab ready-made ready to deliver it on site construction. And now at the construction site, we do the assembling process. So this is one of the BIM modeling by translating 2D drawings into 3D BIM models. Drawing discrepancy between consultants can be detected. Architecture and structural BIM model act as a base model to organize embedded M&E services through 3D visualization. Next one, we have a clash detection and coordination. Clash analysis was carried out to identify issues regularly and resolve them prior to prefabrication. Okay, so this what I've been explained. So next one, we have a documentation. So documentation is a great way to detail out all these components that needed to that needed to plan on IBS manufacturing. Okay, so where's the opening for the pipe and sort of that we can see here in the sample here. Okay. Next one, we have a quantity extraction and cost estimation here. Okay, so I mentioned the ability to extract quantities. So to assist with assessing costing during standard stage and later on, maybe during construction, we can still follow up on the construction, what we have spent, okay, and what has been done on site and what we have been spent on it. Okay. So here, for example, domestic cold water piping length was extracted, estimate cost of pipe items and labor, installation, i.e. installation and patch-up work. Next one, we have a construction detailing. So rebar detail is designed based on the coordinated BIM model. The details are analyzed for performance, constructability, and practicality for transportation to site. Okay, this one of the one of the views from the all-plan software. So the all-plan software, they can put all these rebars automatically. They have been a template, so the calculation are already there, and they put the rebar what needed to be, what are required. Then they can assess it, analyze it, and then straight away to do a prefab automation by the robot. Okay, next one. Here is one of the construction detailing. Okay, so we translate 2D details into 3D BIM to ensure constructability. Build visually to check for slight variation between the typical units. Study possible joint methods between precast panels. Assess design of precast for practicality and logistics. Okay, next one, we have an IBS panel mockup. Okay, so here is the panel mockup that I've been explaining. So having this panel is important to component as a solid prefab panel, and it can work well with the molder. Okay, so this mold they need to design it based on what has been designed in BIM or in the drawing. It's a alternative or the counterpart of formwork that will be done on the what been done on site on situ casting. Okay, take a look here. Okay, next one here is the detail up the components here. So we set out the pipe fittings as per coordinated layout to ensure pipe slope is set correctly. Sanitary pipe size and fittings determined in the correct way that's been designed, and then the pipe sleeve and fittings are placed to provide for openings. Okay. Then next one we have the IBS installation plan. So installation is carried out in two zones, starting from the zone A toward to the zone B. So as you can see, there's a numerical value here. You can see there's a 1, 2, 3, 4, 5, 6, and so on. So these are the zones that needed to be done in sequence. So you can see there's a much smaller value here. You can see the font is 1. So these are represent the panel of IBS. What needed to be installed in the correct sequence to assemble it on site. Okay, so we will start from the zone A. It will depend on the project scale. So this is part of the Pantai Central Park, which is they are using a typical floor and typical unit. There's a few slight variation on the unit on the unit type, but it can be done. So here's the IBS installation plan in a blow up. Okay, so you can have a two team. One is for the slab to assemble the slab and beam, and another team to assemble walls and column. Okay. So here is the IBS installation process. So as you can see here, there's a few workers here. If you can see in the picture here, so the workers are quite a few, because the workers that only need to do a assemble process, because that's already been prefabricated on the manufacturing or on the factory. So as a result, you only need a skilled workers to do a assembling process on site. Okay, but compared to the conventional way, you need a lot of workers to set up the to set up the formwork, and then one is to set up the structural rebar. So having this rebar, you need 3 to 5 workers to do a bending, to do a cutting, right? And then after that, they need to insert it to the formwork. Then they can start to do a casting. So here is one of the simulation process how we look at it on Navisworks. We do a simulation of the IBS sequence, how we install it, assemble it on site. Okay, so that's all the video. You can see it's as you can see how that we put it in the sequence, how the wall how the wall assemble. So by sequence we have a wall first, and then we have a column. Then we can start on building on the flat panel, right? So we are at the end of the last part of journey here, how BIM and IPS can ramp up on the productivity of the construction. Okay, so here what we can see in BIM, in IBS for PS for the Pantai Central Park 3 project. So one of it evaluate constructability and the most cost-effective method of construction. So they have a set of budget, what they need to be done and required for this project uh, to to progress. Okay, so having this method by using hybrid wave, conventional and IBS, they save a lot of money. Then they can invest it to the other thing for the, or what we can say is maybe a green building method. Okay, then we have a we can avoid discrepancies and clashes by identifying them early on visually by using BIM before it's constructed on site. Then we have a visualized detailed information such as construction joint connection. Then we have improved decision making during the design stage coordination on VDC session or virtual design coordination. Okay, so we have a VDC session with our stakeholders, with the consultants, owners, and the contractor. So what I've mentioned just now, we have avoid discrepancies and clashes, and then we presented it to these stakeholders, and they can see what can be done, needed to, what needed to be changed in the corrective manner, and still have a cost effective on this section. Okay, having this feedback from the consultants and the owners helps us to accelerate the process. Okay, next one, we have to improve communication among stakeholders. Okay, so one of the common problem with construction now and before this, the communication between the stakeholders, that maybe one is doing this architecture, one is doing structural, one is doing mechanical, electrical, and plumbing, and they not communicate well to each other. And having BIM as a middle guy, we coordinate to everyone, and we do this on regularly on the VDC session, so everyone can see how their progress, what we can find the discrepancy, what we can find the clash issues. Okay, before they can start even further, we can detect it early on the early stage. Next one, we have a reduced or avoid VO with a well-coordinated model ready for construction. So having all these discrepancies, clashes, just now I mentioned it, we avoid VO, or what we call it, variable orders. So variable orders is where the construction are ongoing, but the designing, there's a design fault during the construction. So this design fault, as a result, needed to be rectified on site quickly. They need to issue a variable order to the contractor. So having this, we can reduce a lot of CO, by minimally spend on the unnecessary mistakes that we've been doing on design process. Okay, so here is my last end of the slide. So I would like to thank you for everyone who have coming in, and we have been doing this for almost 1 hour and a half. Thank you for your time, and I appreciate everyone who has been attend to this webinar, and see you soon. Thank you, everyone, and I send over to the Lisa.
Thank you, Mr. Nazrul, for the engaging and information presentations. Dear participants, now we are moving to the Q&A segments. If you have any further questions, please don't hesitate to type in the chat box. So do you have any questions, dear participants? As we came to the end of today's webinar, I would like to thank to all our participants, and also would like to thank to Mr. Nazrul for sharing their valuable insight with us. And dear participants, please actively join our upcoming webinars, and don't forget to register yourself to the link given. We will be sending out the e-certificate via email to you. And also be sure to check our websites and social media for our upcoming webinars resources related to this. Okay, thank you. Thank you for joining our webinar today. See you soon.